In our previous video, we talked about how to wire utility prepaid energy meter properly, and there is some points I made in lighting, and one of them is a common problem which many electricians do. Hello everyone, this is 𝐄𝐥𝐞𝐫 Electrical Contractors Limited YouTube channel, and this is where we learn through practicals. In our previous video, we talked about how to wire utility prepaid energy meter properly, and there is some points I made in lighting, and one of them is a common problem which many electricians do, and this is about coiling of power cables. In the previous video, I said you should avoid coiling your power cables when you are terminating or installing a utility prepaid energy meter. And in our today's video, that is what we will discuss. With me here, I have two prepaid energy meters, model 𝐄𝐥𝐞𝐫 2017. This is made in China. And then we have a model of 𝐄𝐥𝐞𝐫 made in Kenya, and the year is 2021. That being said, this meter was manufactured prior or before this one. If you look from my video, I have this meter here. This is our first meter, and these are the double poles used to wire this meter. In our previous video, we agreed using two double poles to install or to wire a single phase energy meter will save you a lot of problems, and one was avoiding your meter switching into tamper mode whenever you go to open this terminal cover. So with me I have this meter, which is 𝐄𝐥𝐞𝐫 model 2017 and 2021 model. If you look this meter, like I was saying, it is wired from the cutout. This is our cutout, and from our cutout we have two wires. These are 6.0 square millimeter cable. We agreed it's very important, and you should strictly stick to using the correct size of cables. So for this practical or for this demonstration, I decided to use 6.0, and in most cases you can use 6.0 and above depending on the road of your house. And from the cutout to once where our meter is, we agreed from the cutout you go to the first double pole. This is the first double pole, as you can see, and then from the double pole to the meter, these are the output cable. I mean, these are the input cable for the meter, but output for the MCB double pole C63. Just to confirm, the C63 written here, C63 or 63 amperes. Then from here you go to the next double pole, and from here, that is where we agreed you will be terminating your road cable. Now This is the first meter and this is the second meter. They are both wired the same, because if you look here, as you can see, this is the first double pole and this is the second double pole for the, this is the second double pole for the second meter. If you look the wiring of these two meters, or do you see something wrong with the first or the second meter? I believe a qualified electrician by now can tell where our mistake in these two meters is, and this is the point for today's video. If you're not in a position to tell the problem of these two meters, I can say this. In our first meter, as you can see, our wires have been meticulously terminated, unlike our meter number 2. So the meter number 1, there is no coiling of cables. If you look these cables from here, we have a small curve here, or bed that can be around, because this is not a sharp bed, and then from there our cables are straight up to where the meter is, and even after the meter our wires are straight. We go to the second meter from the first double pole, which is giving the meter the power, or which is supplying the meter with the power from the cutout. If you look our red or live cable, it has been coiled. So it has how many turns? 1, 2, 3. 3 turns. Okay, and then we also have the outgoing cables. These are the wires that will be supplying the road with the power, either in our house or in the consumer box, all to where the load will be. If you look the red again, it has been coiled. How many turns? You can count them. 1, 2, 3, 4, 5 and 6. Too many turns. So looking at this meter, you might think coiling of the cables will make your wiring look neat or smart, but that is wrong. Okay, that is very, very wrong. And even if you have 2 long wires and you don't want to cut them, and that is why you are turning your cables like this, I tell you this, it is very long. You'd rather cut these cables to the required size or the length, rather than having all these turns. Okay, coiling meter, like in meter number 1, is the way to go. You should wire your meter avoiding the turns or the coils. As you can see, this meter from where the cutout is, there is no coils or those turns, unlike meter number 2. We say this is meter number 1, this is meter number 2. So if you wire your meter like what you see in meter number 2, this is what you are going to cause because of making turns or those coils. Point number 1, the problem that will be caused by turning your power cables or making coils is called excessive heat build up. Power cables are designed to dissipate heat along their length. Coiling restricts airflow and prevents heat from escaping, leading to localized overheating. All right. Then we have point number 2, or the problem number 2 that you will experience once you coil your power cables like this when you are terminating your meter, and it is inductive heating and electromagnetic effects. That is the problem number 2 you are going to see. And that being said, it's like when AC current flows through a coiled cable, it creates a magnetic field that induces an electromotive force, which is EMF, in adjacent loops. This can lead to eddy currents and increase the effective resistance of the cable. Okay, are we together? And it is known, if you are a qualified electrician, you know very well, when you make turns to your power cables, one of the common and known problem is where you'll experience something called induction or inductive heating. Okay, and then we go to problem number 3. Problem number 3 is increased resistance and voltage drop. So when you make turns or when you coil your cables, right, during the termination of your single phase energy meter or 3-phase or any other termination, what you're going to experience, or the problem number 3 will be increased resistance and voltage drop. And we also have problem number 4, which is inductive effects in AC circuits. For alternating current AC cables, coiling can create an inductor which may alter the circuit performances and cause unwanted electrical interference. Okay, then point number 5, or the problem number 5 you are going to experience, is the physical stress and damage. Tight coiling can stress the copper conductors inside the wire, leading to internal fractures or weakening over time. It can also deform the insulation. All right, in the insulation, yeah, when I say insulation, it's the outer part of the cable. All right, and then point number 6, or the problem number 6, you will experience a strip hazard and handling issues. Coiled cables can easily tangle or knot, making them difficult to use and increasing the risk of tripping or accidents. Imagine all those problems, 6 problems that you will experience whenever you make all these turns. So to avoid all those problems, avoid coiling your cables. Actually, your job will look, or your work will look neat when you use straight cables, or when you make straight loops like 90 degrees. And then what you should understand is that the best way, or the best practices while terminating or making the loops, and these are whenever you are terminating your meter, you can use loose loops instead of tight coils. The other thing you can do during termination, you can have a figure 8 winding, okay, which is recommended for long cables to reduce inductive effects. Okay, you can also avoid daisy chaining or budding high power cables too tightly, right? Also, ensure proper ventilation around coiled wires to dissipate heat. Imagine coiling your cable like this. Coiling your cable like this. The heat between coils are advised to avoid. As we conclude our today's video, I would urge you to stick to using the correct size of the cable to wire your meter. I have said 6 6.0 or 6.0 square millimeter and above, depending on the road. And then avoid coiling your cables like this, and make sure that your cables are properly arranged or dressed inside the meter box. If you haven't watched our previous video where we were talking how to wire or to terminate an utility or utility prepaid energy meter properly, go back to our previous video and watch. That's all for today. Thank you for watching, and don't forget to subscribe to our YouTube channel. If you like the video, give it a thumbs up.